Hello and welcome to Yebo Tutor. Today we are doing some chemistry. Hello everyone and welcome. My name is Nyasha. I am here to help you out with some chemistry. So what we want to do today is we want to work through as many questions as we can from the 2015 paper. So we are looking at paper 2. I am curious to see if there is someone around who is watching. If you are on Yebo Tutor and you are watching, please drop in a comment. If you are on Yebo Tutor and you are watching, please drop in a comment. So I'm just waiting for a few minutes to see if there's someone around who is joining us for this tutorial. A short lesson that we will go through a few questions in the chemistry paper. So I'm just waiting. As I'm waiting for you, maybe let me just play a little something. Right, I am here to check again. I would like to check again. Can you hear and see me? Is there someone around on Yebo Tutor? If you can hear me, if you can see me, may you please drop in some comment. Please say something on this Yebo Tutor channel. We are streaming live from Nelson Mandela University. Our university is supporting the high school students, right? So we are hoping to see some of you on this channel. So let me just hold on and wait a bit so that you can join us. I hope you'll be able to join us. If you can see me, please drop in a comment. We are working through the 2015 grade 11 chemistry paper. We are working through the grade 11 2015 chemistry paper. So this is paper 2. Mr. James works on paper 1 for physics. So I will be assisting you with paper 2, chemistry. Then our physical sciences can take off. All right. So just in case you are there somewhere and you are watching, maybe this you would be watching the recording there. What I will do is to just scroll through the questions as I wait for the rest of the team to join. I will just scroll through and read through the questions, identify the topics that are related to those questions. And then we will get to a point where we can agree that we can get started. All right. So let's see if there's someone around on a Friday. Let's see if there's someone around on a Friday. Yebo. All right. So as I scroll through the questions, I look forward to see 1 or 2 of us popping by so that we can get started. Right. I am not seeing a comment yet. So let's just take off. Let's just get started. For those that will follow the recording. So what I will do is I will take you through a reading of the questions. And my hope is that anytime now, I will see 1 or 2 of you so that we can assist with any questions that pop by in your head as we work out the topical questions here. Right. So for your first question, the question reads, according to the Arrhenius theory, all bases and so forth. So we are supposed to complete that sentence. So how do we complete that sentence? What happens to all bases? Or what are bases? Or what do bases do according to the Arrhenius theory? Right, so there's some options that are available. The first option is bases are proton donors. The second option is bases are proton acceptors. The third one, bases form hydronium ions in solution. The last one, bases form hydroxide ions in solution. So that's the first question. The second question Question 1.2. Question 1.2 reads, the number of neutrons in an atom of nitrogen 715 is. So we have to complete that sentence. In other words, we need to calculate, we need to find the number of neutrons in this atom of nitrogen. Right. I hope if there was someone around, there's a question that I was interested in having you guys answer when it comes to this nitrogen atom. Right, we are live here on Yebo. We are streaming from Nelson Mandela University and we are working out some chemistry problems. Now let's scroll to question number 1.3. Question 1.3 reads, which one of the following has the strongest forces between its molecules? Which one of the following has the strongest forces between its molecules? The moment you see such a question or you read such a question, what topic pops into your mind? Where do you think this question was extracted from? Which topic do you think this question is addressing? So you're looking at forces between molecules. In other words, you're looking at intermolecular forces. So the moment you think of intermolecular forces, then the question is what happens to that F2, right? So you've got your fluorine gas and another fluorine gas molecule. What happens when they interact? Then you also have the second case, a chlorine and a chlorine gas. So these are different gas molecules, Cl2, Cl2, they interact. Bromine gas molecules, iodine gas molecules. Now, whether they are gas or they are in the liquid state, we have not been told about these, but we obviously have some basics in chemistry to read through so that we can relate to this, the temperatures at which they are in a certain phase. But the question here is, which of these has the strongest intermolecular forces? That's the question. Which has the strongest intermolecular forces? Right, that would be question 1.3. 1.4. 1.4 reads, which one of these four has a tetrahedral shape? Which one of these A, B, C, D, these four compounds has a tetrahedral shape? So you've got hydronium, you've got ammonium, right? So you also have carbon dioxide and aluminum tetrachloride. Which one has a tetrahedral shape? How do we determine the shape of a molecule made of hydronium, molecule made of NH4, and so forth? So your shape construction steps are what are being tested here. Right, so that will cover shape determination, how to come up with the molecular shape. 1.5 reads, two molecules of hydrogen gas at standard temperature and pressure occupy a volume of ... So the question here is just asking for you to complete that sentence and determine the volume that is occupied by two molecules of hydrogen gas. Two molecules of hydrogen gas at standard temperature and pressure. The moment you see STP, what do you think? What comes to your mind? There's some parameters to think about there. Those parameters are useful for you to determine this, this volume. This means the standard temperature and pressure parameters need to be combined to the volume in some equation in order for you to then calculate or determine that volume that is occupied by the 2 moles of hydrogen gas. So we are thinking about which equation has some term on number of moles, which equation has some term on temperature, some term pressure, some term volume, and then we make use of that equation to find the number, the volume occupied by the 2 numbers, 2 moles of hydrogen. All right, I do not see anyone yet. Let me just read through maybe up to question 110 and go and check if there could be another signal somewhere that is supposed to be streamed to. I think I have been given the correct details, and I can see on a monitor that we are indeed streaming this channel. Okay, so the next question is question 1.6. Question 1.6. Right, let me just see if my Zoom is not cutting off some more text. No, it's not. So 1.6 reads, which one of the following statements correctly describes the characteristics of an endothermic reaction? Which one of the following statements correctly describes the characteristics of an endothermic reaction? Right, so you've got to obviously revise the concept of chemical reactions. The heat relationship with the products, the reactants, and so forth. So when we look at exothermic and endothermic reactions, what are the characteristics now for the endothermic reactions? The first quantity that is standing out in these options is delta H. The first quantity that you see in all the options that have been provided is delta H. So the assumption in this question is you understand what the delta H represents. It is a change in what quantity? That delta there. It is simply referring to a change in some quantity. In this case, it's the change in heat. In other words, when the chemical reaction has taken place, if you look at the energy of your products, of your reactants and products, so you've got your energy of the reactants, look at the energy of the products. If you look at if you compare the two, what is the change in energy? In other words, what is the difference between the final and the initial energy in this equation? So the first option is delta H is positive, and the products have less potential energy than the reactants. Second one, delta H is positive. Again, the products have more potential energy than the reactants. And we are obviously talking about chemical potential energy here. C, delta H is negative, and the products have less potential energy than the reactants. D, delta H is negative, and the products have more potential energy than the reactants. So which is which? So this means the sign convention for endothermic reactions versus exothermic reactions is something that you need to revise. In other words, when you calculate delta H is equal to H final minus H initial, the fact that one is larger than the other should produce either a positive or a negative sign. So it is your basic math to solve this chemical problem. 1.7. Which one of the following balanced equations represents a redox reaction? Which one of the following balanced equations represents a redox reaction? So chemical reactions topic. So this idea of identifying the topic is important, because the moment you see the question and you identify the topic, your mind begins to filter out the necessary things, right? The necessary theory, the necessary experiments, the necessary descriptions, and so forth. So the moment you think chemical reactions, the moment you think redox reactions, the next point of contention, right, in this case, is how do I tell when a reaction is a redox reaction? I've been given some chemical symbols. What is the criteria that we must use or that we can use to distinguish a redox reaction from a set of reactions like what we have here? So in the first equation, you just have your proton reacting with a hydroxide ion. So you just have your two ions, and they produce water, or they combine to form water. You've got a solid magnesium in part B that is reacting with copper sulfate to form solid copper particles in aqueous magnesium sulfate. Third one, you have sodium chloride with your lead nitrate, producing your sodium nitrate and your lead chloride. The last one would be your sulfuric acid with your barium nitrate, producing your barium sulfate and nitric acid. So the question is, what should I investigate? What should I identify? What should I look for? Which parameter or which quantity can indicate whether or not a reaction is redox? So redox is what? Reduction, oxidation. So you have both taking place in this question. There we are, our redox question. The second question under redox reactions is the extraction of gold. So the question reads 1.8. During the extraction of gold, zinc powder is added to a solution of gold cyanide to produce gold according to the following balanced equation. So you've got your zinc powder, that's the solid state, and you have your gold cyanide. So it has some sodium, it has some carbon, it has some nitrogen, it has some gold. This will produce the gold, and then you have your zinc combined with that carbon nitrogen molecule. You also have your sodium with that carbon nitrogen compound as well. So the question about this reaction where we are extracting gold is the oxidizing agent. Which is the oxidizing agent in this reaction? How do you identify an oxidizing agent? What is to oxidize? What is oxidation? Or how can I write an oxidation equation? So you look at your available species that are participating. So you have your gold ions, you've got your zinc, you've got your sodium ions, and then that CN compound, that ion. So the next question would be, if we look at each of these ions in the gold cyanide, and the zinc powder, which is the oxidizing agent, right? So that will fall under still your redox reactions. Your 1.9, question 1.9 reads, the volume of a gas at a certain temperature and pressure is V. If the temperature is doubled and the pressure is halved, the volume of the gas will be 4V, 2V, V or half V. So mathematicians, this is your time. This is your time and chance to have fun, mathematicians. This is your time and chance to have fun as mathematicians. Because all you need to now do is, the first part has just told you, so you've just been given information that we're looking for the volume of a gas at a certain temperature and pressure, right? So the volume of a gas at a certain temperature and pressure, which equation relates those parameters for this gas? So the volume of a gas at a certain temperature and pressure. What are the parameters that you have identified in that statement? When you've identified the parameters, what equation or which equation is appropriate to relate them? When you have related them, now the question is, there is a certain first state. So you have this gas at a certain temperature and pressure. So that gas is at a certain temperature and pressure. We're happy. Now that it's at a certain temperature and pressure, there is something that is done to this experiment. They change the temperature. So in other words, they heat the gas. Then the temperature is doubled. It's now twice its initial value. Then the pressure is halved. So if it were a pressurized container, they apply a suction, in other words. So they just reduce the pressure. So the pressure is halved. What will happen to the volume? What will happen to the volume? So if we pressurize something, remember, we pressurize something, it's like a balloon, right? You can inflate it, increase the pressure. So by blowing, you are actually pressurizing it and increasing the pressure. But when your friend comes and they pop the fun, right? They come with some needle. So what are they doing there? So they are just creating an exit point for the air that's in the gas. If we were to take a very slow motion picture, at the very start, there's a very small hole that they create. Then all the gas that is inside that container begins to escape. So in a way, they're actually reducing the pressure of that gas. If we were to stop it after a very short time, very, very, very short time, before it pops and rips itself, we would see that our pressure has reduced. So the question is, if the temperature is doubled and the pressure is halved, what happens to the volume? What happens to the volume? Right, so I am hoping that someone is available to watch this video. And if you are here, please drop in a question or a comment. Please just drop in a question or a comment. What I'm just doing is reading while I wait for you to pop up for our work. Right, so even if you are on YouTube and you are watching, I would like to encourage you to just type in a comment so that we can get started. All right. So you then do your math. So you've got the initial state and the final state. Your equations must be defined for the initial state, another equation for the final state. Happy days. And then you just do the math. So this is where you see that science makes use makes use of a lot of mathematics. You are studying physics, right? You're studying physics. You have used a lot of concepts in physics that assist you to understand what you need to do when you are dealing with a question such as this. One of the basics in your physics, for instance, is just the definition of these parameters. So you know what a temperature is, you know what a pressure is, you know what a volume is. You've also calculated volumes of some objects, let's say in mathematics or in physics. So now interconnect the dots now. So you are conceptualizing from physics, you are applying the chemistry of these ideal gases, you are using the chemical equations. Of course, this one can be used in both. Then you are using the mathematics to then determine what will happen. Right? So it's very exciting to be doing science because you can verify the evidence. So you can tell what's actually happening in a certain process. And you measure and you calculate and you come up with your solutions. So there we are. So we've got our question on the volume of a gas. Now, the last question on the multiple choice section reads, two identical containers M and N are shown below. Container M contains hydrogen gas. Container N contains carbon dioxide gas. Both gases are at a temperature of 25 degrees Celsius and a pressure of 101.3 kilopascals. 101.3 kilopascals. So this is your container here. So that's your container. This one has hydrogen at 25 degrees Celsius at that pressure. The other container, carbon dioxide, at the same temperature and pressure. Right? The next question would then be, consider the following statements. So you're given some statements, then they are saying, consider these statements. The first one reads, the average kinetic energy of the molecules is the same in both containers. The average kinetic energy of the molecules is the same in both containers. Statement number 2, container M contains more gas molecules than container N. Container M contains more gas molecules than container N. The last statement, the mass of the gas in container N is greater than the mass of the gas in container M. So you are looking at three things. Average kinetic energy of the molecules. That's the first quantity. So if you remember how to determine the average kinetic energy of molecules of a gas when you have been given these parameters, you can then compare the first and the second to find whether or not the average kinetic energy is the same. Second, container M contains more gas molecules. How do I calculate the number of gas molecules having been given these parameters? How do I find the number of gas molecules? The number, if I were to open it, take one by one and count them. How can I do that mathematically? So you've got some equations. You've already been given some parameters, right? You've got some temperature, you've got some pressure. So the question is, how do I then find the number of molecules of this gas? The last one, the mass of the gas in those containers. So you're comparing the mass of the gas. How do I find the mass? So the first one, kinetic energy. The second one, the number of particles, number of what? Of molecules. And then the third one, mass of the gas. Mass of that number that you had calculated earlier. Now, the question requires us to pick which one of the above statements is or are correct. So of these three, which is correct, or yeah, which are correct. So obviously this one we don't need to read it out. You just know that the first one, if it's the first one only, which means the other two are false. So this means when you are working through this, you need to first look at the kinetic energy and write true or false. Second one, number of particles, true or false. Third one, mass, true or false. When you now have the two truths, or the one true, or the two falses, or the three falses, whichever way, then you can visit the answers and pick which ones were true, because we're looking for the correct answer. So we're looking for the correct answer. So that would sum up all your questions for the multiple choice section. Now I am seeing that we may not have an audience as yet. So what I'll do is I'll just inquire with a team, see if there probably is a loss in communication with our participants. I'll just inquire with a colleague and see if there is probably a loss in communication with our participants, because while I cannot see comments, the most important is I cannot see views. I cannot see anyone around. So I need to at least inquire so that we may not necessarily waste time if people are elsewhere. Especially you as students, you are the most important in this exercise. We want to comprehend. We want to understand the question. That's the first thing. We want to comprehension of the question, understand the question. When you've understood the question, the next task is identify the given information. What have they provided for us? In the things that they've provided, we should be able to then tell, okay, if they've provided us this in this little story in the question, this is for this particular topic. So in your in your many equations that are in your head as you are learning, then you pick the one that is appropriate, right? So you have identified the topic, you've seen what equations are necessary to use, or what theory or explanations are required. Then when you have comprehended the question and you have identified the topic, then what is the unknown? What exactly are they asking for? What does this question require me to do? Is it a simple explanation? In this case, is it a true or false? So which means there's some work that you need to do. You need to do some calculation. You don't just pick A or B or C, right? You need to understand why you're picking your A and not your B for the multiple choice, for example. So that when you come to these free response questions, so let's take an example of question 2. You're starting this question 2 in your answer sheet or answer book on a fresh page. So the question will just read something like this. Define the term covalent bonding. So this is now up to you. There's no A, B, C, and D to choose from. Define the term covalent bonding. One of the above molecules, that is carbon dioxide and water, has lone pairs of electrons on the central atom. Draw the Lewis diagram for this molecule. So the free response, you don't have any A, B, C, or D. This means it is necessary for us to make use of these textbooks, to study these textbooks, to master the concepts, ask questions in your class, ask your teacher, so that even in a tricky situation for the multiple choice, especially multiple choice, tricky situation, you can easily see or read between the lines to tell, okay, this one is the correct or this one is the incorrect response. Okay, so I will be running a short inquiry in a few minutes. Let me take a short break and then I will be back in, let's say, 5 minutes. Let me be back in, let's say, 5 minutes. If we do not have participants, I may have to shut the tutorial, because the idea is for us to interact, and have fun, answer your questions, and also you answer my questions. And we also answer the questions that are in the question paper. That's the most important, actually. Right, so let's take a break. Okay, I think we will, for the sake of that, those that will be watching the video, I will proceed with working out the first question. And hopefully when you revise it and you get some questions from your revision, then we will interact. Right, so let's jump on to the first question. The first question was on Arrhenius theory. So that's our question 1.1. According to the Arrhenius theory, all bases are... So let's just revisit Arrhenius theory. Or rather, you can just look at acids and bases. So this is your definition. In this case, this is a definition of acids and bases. Acids and bases. So your definition of acids and bases depends on who you're quoting. Acids and bases were defined by Arrhenius. So we've got an equation that Arrhenius bases the definition of acids on, which is the dissociation of water. So the dissociation of water will be defined by an equation such as this. When water dissociates, its chemical symbol H2O, it will dissociate into, so there is, it can also be written as an equilibrium equation, right? So let me just write it as a normal, let's say, unidirectional equation for now. So you've got your hydronium and your hydroxide ions. These are in aqueous state, The first task that we have is to balance this equation, just for correctness, because as chemists, I'm sure you know that it's necessary to have everything looking correct, right? And everything has to be actually correct. Otherwise, we will have problems with the chemical reactions. So we have a hydronium ion and a hydroxide ion. The hydronium ion has 3 hydrogens. So we have 3 hydrogens here, and then we've got 1 hydrogen there. So on the right hand side of our equation, we have 4 hydrogen species. On the left hand side, we only have 2. So which means we need to balance this equation by adding some 2 hydrogens on the side. When you look at the oxygen, the products have 2 oxygen species. On the left-hand side, we can see that we have 1 oxygen atom. So let's balance the equation then. So it means we need 1 oxygen atom and we need 2 hydrogen atoms, as we said earlier. So this simply means that if we were to do that, we simply have 2 of these water molecules. So we have 2 of these water molecules. We have 2 hydrogens, 4 hydrogens on the left-hand side. We have 4 hydrogens on the right-hand side. Our equation is balanced. We have 2 oxygens on the left-hand side, our 2 oxygens on the right-hand side. So we're happy. We now have all our species in the correct quantities, and our equation is balanced. Now, this is the equation on which Arrhenius bases the definition of acids and bases. If you look at, for example, Lewis, there's also a definition of your acids, which is based on what? On them being proton donor or acceptors. However, in Arrhenius theory, your acid will always donate a hydronium or a hydronium ion, right? Your bases will donate your hydroxide ions in solution. So let's just try to get an example. Let's get an example. If you check in your textbooks, maybe you have seen an example like this. So for acids, according to the Arrhenius theory, let's take an example of an acid such as hydrochloric acid, and you are adding some water to hydrochloric acid. So let's just write that we are in aqueous state, and we add our H2O to hydrochloric acid. What will this form, or what will this result in? So this will result in the dissociation of your what? Of your HCl in solution. When it dissociates, this hydrogen combines with what? With this polar water molecule to form the hydronium ion in aqueous state. Plus, this chloride is now free. This chloride is now free in solution. So Arrhenius theorem simply suggests that an acid is the source, or it donates hydronium ions to solution. An acid donates hydronium ions to solution. An example on the base side. So let's look at a base. What is the most common base that you still remember? The most common base in your schooling. What is the most common base in your schooling? Let's take one of the most common bases, sodium hydroxide. So if you have sodium hydroxide in aqueous state, and you will use water to have it dissociate, this will form your sodium ions in solution plus your hydroxide ions in solution. Meaning that, according to the Arrhenius theorem, bases are the source of these ions when participating in chemical reactions. So according to what we are given here, bases form hydroxide ions in solution, and your answer would be, in this case, D. Let me just see if I can circulate that for us so that we can refer to it maybe later on or elsewhere. So that would be our solution. If you have questions on this one, you can just drop the questions through the chat so that we can discuss. Okay, so basically this question is, it requires us to recall the definition of acids. So recall the definition of acids, apply the principle or state the main equation for the Arrhenius theory. Then identify the species. Identify the species. Right, so just for us to see something that could resemble this, let me just scroll to acids and bases and show through that hydronium ion and hydroxide ion contribution. So like I said, this is an equilibrium equation. So water spontaneously dissociates to hydronium and hydroxide ions. So in this small demonstration, I hope you can see it clearly on your screens. So this small demonstration is just showing you that when water dissociates to what? To hydronium and hydroxide ions, you would have, let's say, water at a certain pH. So if we are to take some ions into this solution and measure the pH, we should be able to see whether or not this solution is becoming acidic or not. So this is just to demonstrate what happens when we have, let's say, a strong acid, a weak acid, a strong base, a weak base, and so forth. So what we'll just see here is, for instance, our water dissociating spontaneously. So it changes sometimes. It's hydronium ions and hydroxide ions, and then it goes back to its normal state as water, and that continues spontaneously. So I'll just take, so here what we can see is a beaker in which we have some water. So we have some solution. In this case, the solution is water because I've selected the solution here as water. Then the next thing is you see some magnifying glass. So this glass is representing some very strong magnifying glass. If we could zoom in until we can see the molecules, this is what we would see. So there are some symbols here that I will just make use of. So water is being shown in a color, right? So this is where the understanding or the knowledge, basic knowledge of the names of colors comes in. So I can't tell what that color is specifically, but it is, it seems like it's teal. It looks like it's teal, or should I say a very, very light green, a very, very light green. So let's say the much lighter green color here is the water molecules. Then in here we have the hydronium ion as a red colored ion. Then the hydroxide ions are the purple colored ions. So you have a case where sometimes inside water these dissociate. So you've got a dissociation of the water spontaneously. You've got the hydroxide ion somewhere there, and then the hydronium ion somewhere there inside the water. So this will just show us that when we have water in some container, our pH, water is a neutral substance. So our pH is on the neutral state. It's at 7. So I hope that we still remember that the potential hydrogen or pH can be used to determine the strength of an acid or a base. So basically, this is what we are just seeing here. We just see the water molecule, according to the Arrhenius theory, partially dissociate into hydronium and hydroxide, and then it recombines. So this equation is the basis on which Arrhenius defined an acid and a base. That is Arrhenius, and he defined an acid and a base. So that covers the first question. Let me end with question number 2 today, since it's almost time up. I now, from the comments that I got from our coordinator, Mr. James, I understand that most of you might have to access this as a recording. So which means next time I'll just work through and hope that you will get to revise. Okay, so question 1.2. Question 1.2. Question 1.2, the number of neutrons in an atom of nitrogen is. So what we want is to find the number of neutrons. Let's make use of some symbol for the number of neutrons, right? For the number of neutrons, let's just make it some symbol N. So the basis of our decision for the number of neutrons here will be based on the what? On the atomic symbol. That is what we've been given here. It's just an atomic symbol. So the question would be, if you have some atomic symbol, so there's some atom X, it has its what? Its atomic number and its mass number. How do you determine the number of neutrons? I think from here you may still remember that your mass number is now the sum of your proton number plus atomic number plus your neutron number. So if we are to now compare this to the nitrogen that we are given here, the nitrogen has a Z of 7 and an A of 15. Let's just compare this nitrogen to nitrogen. Let's compare this nitrogen to nitrogen. We can do that by accessing the periodic table. So each paper has a data sheet. So let me just go to the very last pages, page 18. Right, the last pages have what? Have standard potentials. So these are just data sheets. So which means you can actually make use of these often so that you get used to it. So I'm just accessing this periodic table, right? So my point of interest is nitrogen. My point of interest is nitrogen. Right, this periodic table is labeled differently from how we label in the normal textbook. So let me just remind you that according to this periodic table, the mass number is actually written at the bottom. So this is the mass number. The atomic number is written at the top. So that's our symbol for the element. So I'll dash to nitrogen so that we can see some differences. Can you tell me the difference between this nitrogen in our periodic table that I've circulated and this nitrogen in our question? This nitrogen in our question. So this is N15.7. Why or how can you define? What is the definition of this? Do you still remember the definition of an atom of an element? So this is an atom of the same element with the same, obviously, atomic number. That's for the identification, but it is a different mass number. What is it called? So that's your homework. I hope you will send it over to me. Now, so let's then make use of this equation. Let's call it equation number 1. And obviously, this is our A. So in our, if we want to build equation number 2 to find the unknown, I will write the 15 as the A because that is our mass number. So let's write the 15 as the A. This 15 is equal to a Z of 7 plus the unknown number of neutrons. That's the number of neutrons that we are looking for. This is homework. This one is homework. So I hope that I will hear from you. It's a very simple question. So it's just a matter of opening a textbook, then you find the name or the word, then you can get an idea of what it actually refers to. Right. This actually explains why. So it explains why you can actually have an atom such as this. Right. You can have an atom such as this. So let's just jump on to our question. Right, so we are just doing the math now. We want to determine the number of neutrons in an atom, nitrogen 15. So we have come up with equation 2. So if you have an equation such as this, which is equation 2, how can you find this n? What are the steps that you can go through or make use of to calculate n? So to find n, which is the number of neutrons, you can subtract 7 from both sides. Subtract 7 from both sides. So this means on the left-hand side of our equation, we will have the 15. Subtract 7. This must be equal to the 7 plus n that we had. Subtract 7. This way it means we have not interfered with the equation. Whatever we added on the left-hand side, we also added on the right-hand side. Whatever we subtracted on the left-hand side, we also subtracted on the right-hand side. This is not going to change the first equation that was there, right? It's not going to change the equation that we were given. So now we have an equation which we can call equation 3. So let's proceed now. What is 15 minus 7? That is an 8. Is equal to, what is 7 minus 7? Because on the right hand side you can write this as an n plus 7 minus 7. So that you can see that this 7 minus 7 will subtract. So that will then give you an n. So basically, your number of neutrons in this of nitrogen. So I want you to tell me the name of this. You can even send it onto the WhatsApp chat, maybe later or maybe next week, since it's already weekend now. Okay, so that's the number, and our answer is therefore C. Our answer is therefore C. Right, so these were the first two questions that we worked out today. Your task is for you to give me this answer. So the homework that you're getting from what we did today. Give me the answer. Define or what is the term that is used to define or to refer to some atom of a certain element which has the same atomic number, which is why it is the same element, but it is a different mass number, but it's the same element. What is the name of that atom? I need to hear it on the chat sometime. The first one did not have a homework. It did have a homework, so you can look at Lewis acids. So you can look at Lewis acids. So definition of acids, you can then look at different definitions and what they refer to. So which means you can actually then, I can actually then ask you another question and delete Arrhenius theory and put Lewis. Right, so that explains why we have these answers. I hope that these two discussions or points of discussion were useful in some way to you, which means next time we meet, we will continue from question number 1.3. So if you have the paper, this is your chance. Work the questions out, identify where you may have a problem. Then you can share with us when we meet, then I can assist in any way possible. So this is the end of our tutorial for today, our lesson for today. It was basically acid-base definitions, right? Acid-base definitions. And we can even, the second one was then the definition of an atom. It's actually a grade 10 question. This one is actually a grade 10 question. So it's a bonus, right? So it's a bonus. What I just want to do is to quickly create this atom in a small program. So I want to build an atom. Yes, I want to build an atom. So what we want is to build an atom. Let me just clear all that. So this atom has 7 protons that give us the atomic number. So let's see. So this is just a simple, interesting model. What is the name of this model? Do you still remember the name of this model of the atom? I hope you still remember the name of this model. So with this model, what you can do is you can actually see the position of the protons right in the center. Then you've got your orbits for the electrons. So there is a name of this model. Which model of the atom is shown in this animation? So let me I've thrown in one one proton. So the atomic number is what is hydrogen. I've not thrown in any electrons, right? So what do you see? Do you see the oxidation state of this hydrogen? It's already showing you that it is a positive 1. Just because it is a what? It's just one proton. The proton is positively charged, isn't it? The proton is positively charged. So if I do not have anything else that is negatively charged, then this hydrogen will become a positively charged particle. That is why hydrogen is often referred to as a proton. So if we then take one electron and we put it into this neutral atom, we make the atom neutral. This is now the hydrogen atom. And this electron will be busy orbiting around in the first shell, orbiting around at random. Okay, so then what I'll just do is to take 7 particles, which are protons, according to this exercise. 7 particles. So let's add them. That's now 2 protons, 3 protons, 4 protons, 5 protons, 6 protons, 7 protons. We have reached nitrogen, right? According to the chemical symbol that we were given, were we given a nitrogen ion or a nitrogen atom? They even told us that it's a what? It's an atom. So it's a neutral particle. So which means I will need some negatively charged particles to make it neutral. Look at what's happening. Right now, it has a charge of what? Of +6. It has a charge of what? Of +6. Why does it have a charge of +6? It has 7, it has 7 what? Protons. But it has only 1 electron. So I hadn't just added some electrons. So let me just add another electron. We have 2 electrons. Look at the charge. It's now at +5. Another electron. Another electron. All I want is to what? To add 7 electrons so that we've got a total charge, a net charge of 0. So there we have it. We now have our nitrogen is now neutral. The number of neutrons, negatively charged. Look at the charge. It doesn't change. We said we'll add 8 neutrons from our calculations. 1 neutron. There goes. Look at what has changed. What has changed is the mass number. Everything else is staying the same. The charge is still the same, still neutral. So we have 3 neutrons, 4 neutrons, 5 neutrons, 6 neutrons, 7 neutrons makes what? 7 neutrons makes that nitrogen that we saw here. I think it was page 16. No. This nitrogen, which is our most abundant nitrogen. That word. I don't want to give you the answer, right? So it's our most abundant, that word. Homework. So this is what we're seeing there. That's nitrogen. And then for this question, we have another one. So this is the atom. It is nitrogen, but it has 15 as the mass number. So basically, that sums up our lesson today. We basically looked at acids and bases and their definitions according to Arrhenius theory. We looked at the structure of an atom, identifying the mass number, the proton number, the neutron number, and making use of the equation that relates those 3 parameters to find, in this case, the neutron number. So basically that was it. I hope this short exercise was helpful. When we meet, what we want to see in these lessons or tutorials, we want to see inside the chemistry. We don't want to just get 100%. We want to actually understand what to do when we get into a laboratory. We want to understand the chemistry. That's our purpose. When you sit in that exam and then for some reason you've forgotten something, you shouldn't get stuck. Why? Because you've been studying, and the idea is, if you have been studying and you understand the concept, then it means if you forget something somehow, we all forget, I also forget. When you have forgotten, what you will do is you will rebuild from memory, from the basic principles, apply to the specific question, so that you can end up actually acing it and getting distinction. Right, so I wish you the best, and I will end this tutorial by just closing and just saying have fun, have a safe weekend. Thank you for your time. Bye-bye.